Hello, this is Sophia, and we are going to go over a homework problem in Ohm, especially homework 3.5 of Precalculus that has to do with reference and co-reference angles. So I believe I'm sharing my screen, so you can now see here the particular problem that we are solving. It comes from a student's homework. And to introduce the concept of how these problems will be solved, we need to understand what is a reference and what is a co-reference angle. So they will have a problem where you are asked to find the value or an expression for the trigonometric function of a given angle. So your given angle, we will call it phi in this video. And in this particular problem, it is the angle of 311 degrees. And another given angle is the angle of negative 41 degrees. And what they want is they want you to express your angle in terms of 49 degrees. And 49 will be the reference or the co-reference angle. And in this video, we will call it theta. So let's talk a little bit about reference angles and co-reference angles. When you have a given angle in standard position, phi, so let's assume that my given angle looks like this, and this is my phi. So this is an angle in quadrant 3. Then the reference angle is the angle made with your terminal side and the x-axis, and it has to be acute and positive. So in this particular case, my reference angle will be this theta over here that the terminal side makes with a negative x-axis, horizontal axis. So if you have your angle phi that is in quadrant 3, the trigonometric functions of phi is equal to the trigonometric function of your angle theta, which is your reference angle. And the only difference would be that you don't really know if you will have the same sign or opposite signs. And that is because theta is an angle in quadrant 1, it's acute. So all the trigonometric functions of theta are positive, but in this particular example, phi is an angle in quadrant 3. And in quadrant 3, the cosine is negative, the sine is negative, the tangent is positive, the secant and the cosecant are negative, and the cotangent is positive. So depending on whether the trigonometric function of your angle phi is positive or negative, you're going to use the appropriate sign when you are evaluating in terms of a trigonometric function of theta. Remember, the trigonometric functions of theta are always positive numbers. So in a similar manner, a co-reference angle is the angle that your terminal side makes with the vertical axis now. So if I have, say, an angle phi, and let's assume again phi is in standard position. Let's assume that it is a second quadrant angle phi. Then the co-reference angle will be the acute angle made with the vertical axis. And in this particular case, this will be my theta. And it's made with the positive vertical axis. So the co-reference angles have their cofunctions equal to each other. Again, depending on the quadrant that your angle phi is in, you are going to choose a plus or a minus for the cofunction of theta. Remember that theta is an acute angle, meaning it's in quadrant 1. Therefore, all its trigonometric functions are positive. But in this particular case, phi has positive sine, negative cosine, negative tangent, positive cosecant, negative secant, negative cotangent. So the co-reference angles, though, switch their cofunctions, which means the sine of phi is the cosine of theta, and the cosine of phi is the sine of theta, and the tangent of phi is the cotangent of theta, and the cotangent of phi is the tangent of theta. So the trigonometric functions that share the same name with either the co prefix or without it are the cofunctions, and they switch. So not only you will switch the function, but you will also check to see if you must keep the positive sign or make it negative. So in this particular problem of our homework, they are giving us information about the angle of 49 degrees, and then they are asking us to express the cosine of 311 degrees as a function of 49 degrees, and the cosine of negative 41 degrees as a function of 49 degrees also. And notice that theta is our 49 degrees, which is a positive acute angle in quadrant 1. So I need to find where 311 degrees lies. So this is my trigonometric circle. 311 degrees is in quadrant 4. So this is my phi, 311 degrees. And the 49 degrees is actually the reference angle. So it is the angle that 311 makes with the positive x-axis. So since these are 49 is the reference angle, the functions stay the way they are. So the cosine of 311 has to be equal to the cosine of 49. And now I have to determine the sign. Is it plus or is it minus? 311 is in quadrant 4. The cosine of 311 will be a positive quantity because 311 is in quadrant 4. Therefore, this will be positive. I can write it or I don't have to write it. So the cosine of 311 will have the same sign and the same value with the cosine of 49. Now, where is negative 41 degrees? Negative 41 degrees is also in quadrant 4. It is a negative angle. So it goes like this. This is negative 41 degrees. And 49 degrees is the co-reference angle. So it is the angle that negative 41 makes with a negative y-axis. So this is 49 degrees. Notice that 49 degrees is a positive acute angle. So since 49 is a co-reference angle to negative 41, then the cosine of negative 41 has to equal the sine of 49. And now the question is it going to be plus or minus the sine of 49? Since 49 is in quadrant 1 and its sine, cosine, tangent, they are all positive. But what is the cosine of negative 41? Well, negative 41 is in quadrant 4. And in quadrant 4, the cosine of 41 is a positive quantity. So therefore, this will also be the positive sine of 49. Now, what else are they giving us? They are also giving us information about the tangent of 49 to be equal to n. And in this particular case, I prefer geometry to algebra. So the way I'm going to do it is I'm going to actually draw a right triangle. The nice thing about right triangle is that it is used for acute angles. So acute angles are also in quadrant 1, and therefore they could be the reference or the co-reference angle, and all of their trigonometric functions are positive. So if I assume that this is 49 degrees, they told me that the tangent of 49 degrees is equal to n, and I'm going to write it as a fraction, n over 1. And I know from right triangle trigonometry that the tangent will be the opposite over the adjacent. And that means that the opposite is n and that the adjacent is 1. And if I do Pythagorean theorem, the hypotenuse will be 1 plus n squared, square root of 1 plus n squared. So I know how to write the cosine of 49 as adjacent over hypotenuse. So in terms of n, it will be adjacent, that's the 1, over the hypotenuse, which is the root of 1 plus n squared. And the cosine of negative 41, we said that it is equal to the sine of 49. And from this right triangle, the sine is the opposite over the hypotenuse, so it would be n divided by the square root of 1 plus n squared. So I'm all done, and I was very lucky because here I had positive signs, so I didn't have to worry about the signs in these expressions. And this is my answer. I hope this helped. I'm going to stop recording.